everyone. Here in this video, we are talking about Pascal's law, its application called hydraulic lift, and we will also solve a problem to make this concept more strong and strengthened in our head, right? Let's start with Pascal's law. What is that Pascal's law tells you is in the case of an enclosed liquid, in an enclosed liquid, pressure is increased at any one point of that liquid. If pressure is increased at any point in the liquid, that increase in the pressure is transmitted to all parts of liquid uniformly without losing at any place or without any diminishing effect. That means you give pressure at one point, it is being felt at every other point of that liquid. That law is that simple, right? So taking this into consideration, taking this Pascal's law into consideration, that means to say that if at a point you give some pressure, its pressure is being there everywhere else. That means if we had given a force at a particular point per unit area, it is spread or passed all across. That's the meaning of that, right? Let us try to understand what's the meaning of that Pascal's law by knowing about a concept called hydraulic lift. Let me talk about a hydraulic lift. So this hydraulic lift application even explains the concept of the Pascal's law very simply, straightforward. Let us see what this hydraulic lift is. It is simple. The name itself tells you like it is lifting with the help of a hydraulic. It's a kind of a fluid or water itself. So let us imagine a kind of a system like this. This is the system. One side of a system is having a thin opening. Other part of the system is having a thick opening. Now, this system is, imagine that it is filled with liquid, water at all, like this. It is filled with water. Now, let us say here we have kept a body. You can imagine a kind of a platform here over the water. You have kept a big body. This body, you want to lift it up this way. To lift it up, actually, it's having its weight always acting in downward direction. So to lift it up, we shall apply equal force acting in upward direction. Who will apply that equal force? This liquid will apply this equal force. So what do we do is, from the other end, let us apply some force, F1. This force will be transmitted to the other part. Let me call that as F2. Now, the areas of these parts are different. Here, the area on which the force is acting is A1. Here, the area on which the force is acting is A2. But this is a liquid that is there in an enclosed material. Here, you have applied a force on a given area, that means there's a pressure. As per the Pascal's law, all that pressure is passed to all parts of the liquid, that is, the second end of this part also undiminished. So I can say pressure applied here at this point is equal to the pressure exhibited here or executed here. So I can say simply as per the Pascal's law, the pressures are same. So pressure formula we have force acting per unit area F1 by A1 equal to F2 by A2. So if you want to know how much is that F2 is, just get this A2 to this side. A2 by A1 multiplied by F1. Now, one thing is very clear if you look at this application little carefully. We are very much clearly visible that this is A2, this is A1. area 2 is much bigger than A1. Then this factor A2 by A1 will be much bigger than 1. So when you apply F1 force, because of the Pascal's law that the pressure is equally distributed, this is very clearly multiplied by a factor of A2 by A1 and multiplied to what? F1 becomes larger F2. So to lift this body, actually we need a lot of force. You applying that much of the force needs a lot of energy and a lot of a kind of a involvement that you need to do. I want to do that job much simply, much easily. So what I'm doing here is I'm actually applying a smaller force itself, F1. That's being multiplied as F2 because of the law that we are talking about called Pascal's law. So this way we can lift a hydraulic lifts and you can see the hydraulic steerings for the heavy vehicles where you apply a small brake on the pedal that becomes big and stops the entire big vehicle itself. So this is all simply an application of our Pascal's law itself. That's called, the application is called hydraulic lift. Anyway, to strengthen this concept, I just want to do a small problem on this concept, right? Let me do a small problem here. Yes, I will write a problem for you first of all. The problem is like this. It's an application of our Pascal's law itself, hydraulic lift itself. The problem is like this. There are two tubes of diameter 1 centimeter and 10 centimeter. They are, one is a small tube, another one is a big tube, are filled with water, filled with water and are connected, connected with a rubber fitting. Now my question is, if a force of 10 Newton is applied on smaller part, how much force acts on bigger part? So this is the kind of a question that I want to solve. This is simply a direct application of our Pascal's law itself. Let me explain how it's an application, right? Well, let's try to understand what is being given for you. He says there is a thin tube connected to a thick tube. This one, the first one is having a radius of 1 centimeter. The second one is having a radius of 10 centimeter. It is filled with liquid water. Now, it is being said that here a force of 10 Newton is applied. Here that force becomes how much? That's a question that's being asked. So simply here you have applied a pressure P1. That pressure will be forwarded as per the Pascal's law that in a kind of a closed liquid and closed liquid, wherever you apply a pressure, it will be just distributed across the liquid at all points. So I can write F1 by A1 where this is the area A1 equal to F2 by A2 where this is the area A2. What is F1 is being given to you as 10 Newton. Area is pi r square, assuming that these are having a circular shape. Pi r square, that is, this is being given like a diameter for you, so radius becomes half of it, that is 1 by 2 whole square. Let me take it in centimeters itself on both sides so that they can be cancelled. F2 you want to calculate, pi r2 square is diameter by 2 whole square. So if you simplify this a little further, F2 will become pi and pi can be cancelled. 10 by 2 whole square by 1 by 2 whole square multiplied by 10. I have just rearranged the terms, right? Taken this to this side. So 10 square is 100 by 4. 1 square is 1 by 4 multiplied by 10. 4 and 4 gets cancels. 100 into 10 becomes 1000 Newton. That's great. Have you seen what happened? Have you seen the magic that was being happened here? Here you have applied just a force of 10 Newton. That force became 1000 Newton. That's the magic of the Pascal's law.